Okay, so Leetcode practice time. Clone the graph. So given a reference of a node in a connected undirected graph, return a deep copy of the graph. And each node is defined with a value of integer and list of its neighbors. Okay. Yeah, so I think regardless of the explanation here, I think we should be good about what we understand about the problem, like the decopy. It's essentially we need to copy we have exactly one copy for each of the node, and the linkage between the nodes should be what we have created for the mapping node. Alright, so the first goal for this video is to find the solution. So the solution for this one, we could do it either in DFS or BFS, I would say. And the other thing is to see how they behave in a real interview if you're given this question. So in a real interview, regardless of the question, always try to understand the question at first. If there is anything you need to clarify, please bring up the questions. And also think about the edge cases. So in this one, I would say the edge case here is, suppose the node for the given input is empty, is a non-pointer. So in that case, we just return a non-pointer. And after we clarify the edge case and we fully understand the problem, the next step is about to think solution. So as I said, I think either BFS or DFS should work, and both of them is going to take all of n as the runtime. Space-wise is also all of n. So n defined as the number of nodes within this graph. The third one is about coding. So in the coding part, we care about the code correctness and the code readability. And after we code, we need to do some testing. But I would say in this one, it is quite hard to explain, to go through a test case manually. But we could still do it. Let's do some coding work first. Let's turn our idea into the solid code. So for this clone graph, we are going to. So first of all, we need to define the copy. We need to define the mapping relationship between the arrange node and the copy node. So let's say we just define a private thing here. So let's define map as okay. So I think it's quite it's not a good idea to define some private or public member for this solution for the class, but instead let's define some local variables. So first of all, let's define in map node and node. So it's the node map as new hash map. And let's define another function. Let's call it node DFS. Okay. Actually, we could do it. Let's say we have the void thing as we have void as a return value type, and the one parameter is a node, and the other one, of course, is the hash map. Node map. Okay. Then in this clone graph, we are going to call DFS. Let's define it as a private function. It would make more sense here. So we are going to do DFS and then node map passing into it, and finally we return node map.get node. But one thing I think is worth to mention is hash case we first bring up when the node is a non-pointer. We just need to return a non-pointer here. So in this DFS, first of all, we need to see whether the node has already been visited. So if it has been visited already, it means that we have already created a copy node for it. So if node node map dot get node, if it contains the key, if it contains key of node, then we just need to okay, so we actually need to define the return type as node. We just return what is that? We just return node map dot get node. Okay. Otherwise, it means it doesn't contain the corresponding node. So what we would do is we would need to go through this. So for this one, if we haven't encountered the node before, we will need to do a copy of it. So it is going to be node copy node is equal to new node with a value as node dot value and a new array list integer new array list node. Okay, so that's the copy of the node, and we also need to go through all the neighbors for the arrange node. For node neighbor, it is node dot neighbors. So copy node dot put dot what is that? It is dot neighbors dot copy node dot neighbors dot add. Okay, it should be this as DFS. It's DFS neighbor, and also what is that? It is a node map. Okay, so actually, since we have the return value here, we just need to return DFS here. Okay, so I think that should be it. Let's check if there's anything missing here. So if the node map already contains a node, we just return the original node, and we copy this, and we need to put into the hash map actually dot put the node and the copy node, and then we go through the neighbors of this node and we copy all of it, and finally we will return the copy node here. So for go through all the neighbors of the node, we would add whatever DFS returns us. Okay. Sure. So I think it's pretty much code complete. Let's see the testing. It's really hard to do the testing, but if you have time, please give a brief explanation by going through an example to see how this piece of code is going to work. But let's just do some sanity check here. So for a given node here, we first initialize a node hash map, pass it into the DFS, and starting from the node to do a deep first search. If the node map already contains this node, which means we have already created a copy node for it, then we simply return the node map.get node. Okay, and otherwise otherwise we haven't encountered this node before, we are going to create a copy of the node, and we just put the relationship, the original node and the copy node, into this node map. We go through the neighbors of the node and we put the new neighbors, the copy neighbors, into it, and then we return the copy node. Okay, so let's run this code and give it a shot. Okay, it's accepted, and let's do a submission. Okay, so we should be good about this this piece of code. And regarding the test case setup, definitely set up a test case. Let's say node is equal to none, and also set up some test cases, like for example it contains one node and also multiple nodes. I would say that's good enough for the test coverage. So that's it for this coding question. If you like this video, please give me a thumb up, and I'll see you next time.